Welcome to the lesson, Areas of Shapes Made of Rectangles. There are two parts to the lesson. This is part 1. The lesson assumes that the students know how to calculate the area of a rectangle, and it will help the students see how they can use this knowledge to calculate the area of a wide variety of shapes. Let's move on to our first shape, and we read the question to the students. What is the area of the following shape? Try to find different ways to solve the question. A student could say, for example, we didn't learn this yet. We only learned how to calculate the area of a rectangle. Some students may simply count the squares. The idea we hope the students come up with is to divide the shape into rectangles that they do know how to calculate. If you are working with a wireless mouse, it can be handed to a student who wants to show a solution. Otherwise, the student can come to the board to show his or her solution. For example, showing one rectangle and another one. The area of this rectangle is 2 times 6, which is 12, and 2 times 3, which is 6. 12 plus 6 is 18. Another student could see the division differently. Here is one rectangle, and here is another. So here we have 2 times 4, 8, 2 times 5, 10, and we reach the same answer. It may seem obvious enough to us teachers that we will get the same result, but this is not necessarily so for all students. See if the students can come up with another division. Now let's move on to the next page, where we prepared 3 solutions. We have the color division, the relevant multiplication for each rectangle, and the summation of the areas of the rectangles. And now we move on to the student worksheet. This is a page we print out and give the students. Let's have a look at the page and explain. The first 4 questions are in the same format as the example. The students have to think up a way to divide each of the shapes into rectangles that they know how to calculate. The 5th question looks very different. Rather than the shape being divided by a grid, the lengths of the sides are given. This might be challenging to some of the students, and you can walk around the class as they work and give small hints as needed. The last 3 shapes at the bottom are for a different task that we will present later on. After the students finish working, let's review their answers in the app. Question number 1. As with the example, call on the students to give their solution. One possibility seems to stick out fairly strongly. Rectangle 1 here, and rectangle 2 here. You can always ask if another student did it differently. In this case, you can choose the gray color and color the shape gray again. On the next page, we have the solution. Question number 2. Here there are a few ways to think about the problem. The rectangles could be this one, and this one, and this one. Another possibility, for example, would be to extend these all the way here. In class, you could see what solution was most common and which one was most unique. On the next page, we have a possible solution, and we move on to the 3rd question. This question is special. The shape can be divided into rectangles in a similar way to what we saw previously, but there is also a very different approach that can reduce the number of calculations needed. It will be interesting to see if any of the students thought of it. If not, you can give a hint before showing the solution. This could be a visual hint. Let's move back and color only this square. If this isn't enough, you can give another hint with a scribble tool and mark this area. The solution we are aiming at is this. If we imagine this square moving here, then we're left with only one big rectangle, 5 times 7. Let's move on to the 4th question. In class, of course, you can take your time, but here we will skip to the solution. And then you can go back and ask the students if the previous method can work here as well. The answer is that it can. Let's see this solution, and here it is. We can create a 5 by 5 square. Now we move on to the 5th question. Some students may be taken aback by a format that looks very different than what they're used to. And it's important to encourage these students to look at the question and see if they can find a way to approach it. So first of all, even before knowing how to calculate the answer, the shape can be divided into rectangles, like this with the line tool. We click it, then we click at the starting point and drag. And again. Now let's use the scribble tool and see what rectangles we can calculate. In this rectangle, we can see the numbers 3, 4, and 5, but the relevant numbers for our calculation are of course 4 and 5. So the area of the rectangle is 4 times 5, 20. You may have another student give the calculation for this rectangle. Here we have 4 times 7, 28. To calculate the final rectangle, we have this side, which is 4, but we also need this side. Try to make sure in class that a fast student doesn't just give out the answer. We can right-click on a scribble to erase it, and an important hint could be to emphasize the 3 and the 5. At this point, more students might be able to understand that the length of this side is 2, because the 3 plus this length has to equal 5. And now we can calculate 4 times 2, 8. On the next page, we will see the result. Let's continue. This second student worksheet refers to the 3 shapes that we saw at the bottom of the first student worksheet. Let's see them again. Here they are. Let's see what we do with them. On the next page, you will see the following shape divided into 15 squares. Let's see this. Here are the 15 squares. Here are their areas. We see here 3 types of squares used, 1 by 1, 2 by 2, and 3 by 3. And here we have the calculation of the final area. 7 times 1, 7 squares of 1, 7 squares of 4, and 1 square of 9. And the question for the students is as follows. Divide the shape into a minimal number of squares. Emphasize that the students have to use squares, not rectangles. Instead of only using the division of the shape as a method of calculating the total area, the division itself is turned into the riddle. This makes the task more interesting and challenging for a wide range of students. First of all, no student will get stuck and not be able to divide the shape into squares. This is because a square with an area of 1 can always be used. After a student, any student, reaches a certain solution, the goal is now to prove upon yourself and see if you can use less squares. Let's start solving this question. It seems that if we want a minimal number of squares, we want the squares to be as large as possible. The largest square that we can find here is a 5 by 5 square, such as this one. After this, we have to cut off squares which are 2 by 2. This one, here, and again, and another 2 by 2, and now ones. 1, 1, and 1. In total, 1, 2, 3, 4, 5, 6, 7, 8. You can walk around the class, and if a student calls you and says he or she finished, you can tell them that this result can be improved. It is possible to reach a division that requires only 7 squares. Let's see the solution. Here we have solutions with 8 squares, and here are solutions with 7 squares. Even if a student finds a solution with 7 squares, you don't necessarily have to tell them that they reached the best solution. You may ask them to try to make sure that there is no better solution. This requires the students to organize an orderly scan of the possibilities. This practices higher level thinking. This is why this task is perfect for a heterogeneous class. Each student will deal with the problem on his or her level. Let's conclude. What did we learn? Calculating the area of a shape by dividing it into smaller rectangles. Beyond this, as teachers, we would like to emphasize that the tasks were created to promote flexible thinking. The students also encountered a question that might look different than what they're used to, and hopefully they will see that they can still deal with it. And finally, we had a question that is more of a riddle than a simple task to allow each student to stretch his or her cognitive ability. And that's it. We hope you enjoy this lesson in class.